shows the time is in seconds, by 93 children to solve the puzzle. So total frequency is nothing but 93. So that means the sum of this entire frequency must be equals to 93. So now we also have this frequency distribution table, and we need to first of all figure out what is the value of P and Q. So first of all, for P, the time taken between 65 to 75. So 65 is here and 75 is here. So how many students exactly took the time between 65 to 75? That's clearly there are 17 students who exactly took the time between 65 to 75. So that is the reason. So 75 is the, 17 is the value of P. And if I talk about Q, so the number of students who took the times between 95 to 105. So 95 is here, 105 is here. So these are the number of students. So that means it's clearly 11 students. So these are the values of P and Q. Now, if I need to figure out what is the median class, so totally we have 93. So whenever we need to find out the median, this is for part 2. For median, the formula goes something like n plus 1 by 2th term, where n is the total number of children in this case. So in that case, for this sum, so this one has to be 93 plus 1 over 2th term. So that's going to be 94 over 2. So which is nothing but 47th term. So 47th term would be my median. So now till here, if you calculate it, so there are 7 terms are over. So that means there are 7 students are over, and till here, so it's 7 plus 14. So 7 plus 14 is 21. So 21 terms are over, and till here 21 plus 17. So it's like we need to calculate the cumulative things. So 21 plus 17 is 38. So 38 terms are over here, and till here 38 plus 20 would be 58. So now if I talk about my 39th term, so 39th term would be somewhere between 75 to 85. If I talk about 40th term, that's also between this up till 58th term. So even the 58th term would be between the 75 to 85. So that is the reason 47th term would definitely be between the 75 to 85. So that's the reason the median range, median class would be 75 to 85, where the time is between 75 to 85. Now for part B, a child is selected random. Find the probability that the child takes less than 95 seconds to solve the puzzle. So if I talk about the total number of childs who take less than 95 seconds to solve the puzzle, so that's basically the sum of this entire thing. So in that case, this is going to be 58, and 58 plus 18. So this, when you add all these stuff, so that's going to be that's going to be 76. So now if I talk about the total number of the probability of the child takes less than 95 seconds, so that's going to be the number of childs who takes less than 95 takes less than 95 seconds divided by the total number of total children. So in that case, so clearly the number of childs who takes less than 95 has to be 76, and the total is 93. So 76 over 93 is the right answer for the sum. So if you're finding the decimal answer, this one has to be 0.817 approximately. So this is the right answer for part B. Now, if I talk about part C in the sum, so we have it something like consider the class interval 45 to 55 and write down the interval width. So the width of this interval is, so you just need to subtract it. So when I subtract it, so it's basically 55 minus 45, basically the difference between the higher and the lower bound, so which is nothing but 10. So write down the mid-interval value. So for this one, the mid-interval value means we just add them and divide that by 2. So 55 plus 45 by 2, or basically 45 plus 55 by 2. This is 100 by 2, which is nothing but 50. So 50 is the mid-interval value. So now, using this concept of mid-interval value, so we need to figure out what is the mean and what is the standard deviation. So for the mid value for this one, this is going to be 50. And for this one, it's going to be 60, and this is 70, and this one is 80. These are the mid values, 90, then 100, and 105. Sorry, 110. And we know all these frequencies. So this is going to be 7, and this is 14, and this one is basically 17 and 20, then 18, then we have this 11, and finally we have this 6. So now the mean of any data, so we can always find the mean, something like this. So mean would be equals to summation of data into frequency. So which is, you can also say it like frequency into data divided by summation of frequency. So which means, so we need to do it like 50 times 7 plus 60 times 14 plus 70 times 17 plus 80 times 20 plus 90 times 18 plus 100 times 11 plus 110 times 6. And this entire thing divided by sum of frequency. So sum of frequency means it's 7 plus 14 plus 17 plus 20, basically the number of child. In this case, the number of childs is given as 93. And when you simplify this, you will be getting the answer something closer to 79.1. So this is the right answer for this sum. And now if I talk about standard deviation, so let us keep this value of mean in our mind. So mean of this data is, let me represent it with x bar. This is going to be 79.1. Now, in order to calculate the standard deviation, so we need to use this formula. So the standard deviation formula, so which is basically the formula for variance, would go something like, which is sigma square is the variance, where sigma is the standard deviation. So it's going to be summation of frequency into data square divided by summation of frequency minus x bar square. Or we can also use the formula of summation of frequency into x minus x bar square divided by summation of frequency. So both the formulas would work. So now I'm going to use this first formula. So that's going to be sigma square is equals to, so in this case, I'll be getting summation of sum of frequency into data square. So which is nothing but frequency is 7 for the first one. So it's basically 7 times 50 square plus this is going to be 14 times 60 square. We are taking all the mid values to calculate this. Then it's 17 times 70 square plus then it's 20 times 80 square, then it's basically 18 times 90 square plus 11 times 100 square, and finally it's 6 times 110 square, and this entire thing divided by the sum of frequency is nothing but 93, and this entire thing minus mean square. Okay, it's not just mean, it's the mean square, and mean square is going to be 79.1 square. And when you simplify this, so you will be, and also when you take the square to the other side, so we'll be getting whatever the answer you'll be getting it here. So it will be sigma would be equals to square root of this entire answer. So this is going to give us the value of 16.4 approximately. So 16.4 is the value of the standard deviation. Now, if I talk about the last part, John assumes that t is normally distributed and uses this estimation, the probability that the child is less than 95 seconds to solve the puzzle. So find the John's estimation. So what do you mean by this? So right now we have these values, so mean and standard deviation. So standard deviation is 16.4. So now what we are going to do is, so we have to use this normal distributions now. So we are talking about a normal distribution with a mean where x is, let me take t as a random variable, which is normally distributed with a mean of 79.1 and with a standard deviation of 16.4. So usually it would be like mu comma sigma squared. That is why I'm representing it like this. And in this one, so we need to figure out what is the probability of t is, the random variable is less than 95 seconds. So what is the probability that the child takes less than 95 seconds? So if I'm solving this using the normal distributions, so this is how it would go. And we need to use the calculator to simplify this to find the answer. So in this one, so we have to go to this normal CDF. In normal CDF, the lower bound is going to be very, very lesser value. So if I talk about drawing the curve for this one, so the drawing the curve would also look something like that, the normal distributions. So I have it something like this curve, and it's basically symmetrical about the mean. So my mean in this case is 79.1. So in that case, so when I say t is less than 95, so suppose if 95 is around here, so we need to figure out all the probability which is less than this. So in that case, my lower bound has to be some very, very less negative values, or very, very high, basically the very large negative values. So that's why I'm leaving it as negative 9E999, and the upper bound is 95. We are finding the area or a probability up till 95, and the mean is given as 79.1, and the standard deviation we know it as 16.4. And when we solve this, we will be getting the answer something around 0.8338, or you can also just say it like 0.834. So this is the right answer for this sum.